So today we're not going to, I'm going to do my best not to read to you. You guys are all very literate individuals, but there's a couple points in this presentation I will. Just so I have the opportunity to stress a couple of points. So the H2S release rate for every potential zone that may contain H2S gas is determined by multiplying the maximum H2S content and the AOF rate as determined by the geological engineering review of the available data. The paired data points need not be from the same well. The sum of the H2S release rates from each zone becomes the cumulative release rate for the drilling, completion, servicing, suspended producing as applicable to the project. The reason I've read this to you, just this is the core of how an H2S release rate is established, also the core of how the H2S search has been built. So, speaking to the H2S search, what we are doing is we are identifying every potential zone that you could hit, where for each of those zones, we're going to go and do a search for all the gas analyses and flow rates as applicable. We're going to choose the highest or the most representative gas analysis and flow rate, use those to calculate the release rate for that formation, and then provide the cumulative H2S release rate for every formation, giving you the instance that if you were to have a blowout on every formation that you're exposed to at any given time, that is your worst case scenario. So that's what the CAPP guidelines have designed this process around, also how the H2S search is built. In section 2, as we were talking about the maximum H2S release rate determination, they are speaking again to the EPZ calculations. So again, the Directive 71, they have stepped in and they have governed the calculation of a release rate, requiring that industry uses ERCB H2S software to calculate. So with this, CAPP no longer really advises, but they simply refer to those regulations now. So with this, there's a clear distinction between Directive 56, which is laying out what is necessary to do an H2S release rate. You come up with those results and those numbers, then you take those numbers and plug them into the ERCB H2S software, which is governed by Directive 71. So there's a little bit of gray area with respect to an EPZ calculation, simply because it was pretty much designed by CAPP, not by ERCB, but ERCB has since stepped in. So a quick note, though, for our users, you will know that the old EPZ calculation still exists in the report, and we do that for a reason. Not all jurisdictions obviously recognize this. This was built by the Alberta government. And in some situations, there is still a reference back to the old formula. So if you're drilling a well based on current regulations, but you are making reference to EPZs that were making reference to wells that were drilled in your vicinity, but those EPZs were built off of old calculations. It has come up a couple of times where it'd be nice to have that reference to the old calculations so that you can compare apples to apples. Okay, so while you will still see an EPZ in our report, just know that the ERCB will not recognize that calculation anymore. Okay, on to section 2.2. The CAPP guidelines have laid out a very nice process flow just to describe the steps involved in coming up with an H2S release rate. So the order comes down to that there is a well to be drilled. You need to get the license. In order to get the license, you need to do your H2S release rate assessment. In order to do that, have your geological prognosis on you. The H2S search will guide you along, but really without that prog, you're kind of you're swimming upstream. You need to have that geological prognosis, and that prog does need to be a very reliable source of information for the geology that you're going to encounter. Just a quick note though, some operators are actually considering H2S prior to even licensing, so it's not even a drilling task with some of our clients. This is actually a surface land task. And for those who are even considering H2S prior to licensing, there are still guidelines and rules that those departments can follow as well. By no means is it necessary to come up with a fully complete H2S release rate assessment prior to licensing, but you can still follow a lot of these processes even at that point too. So If you don't have a prog at that point, not the end of the world, but just understand you won't have a complete H2S release rate assessment. Next on the line is to summarize the formations that may be productive and identify the casing points and hole sections. So the process here, the H2S search, will start with all formations, any formation that you could potentially hit. We're going with a very conservative search for formations. The question at this point is not whether it's productive or not. The question is not whether it's sour or not. It is just, is the formation present and will you be exposed to that formation? That's all you're asking at this point. And in fact, you're not even worrying about the data at this point. What formations have we touched on and is it present? We'll worry about the data next. So if you open up the report and you see that there's a 15% gas analysis and it strikes you as odd, don't worry about it yet because you may in fact end up knocking out that formation anyway. Okay, collect and validate the gas analysis data. So for every one of those formations, you need the gas analysis data to represent that formation. You need the flow rates to represent that formation. So we will touch heavily on the search criteria later on. So I won't speak to this too heavily, but you're going to hear me mention this term several times, the term geologically analogous. There is a lot of subjectivity around how far do I search, which pools do I touch on, what, is a 5-kilometer search enough, 10 kilometers? The theme is always around geologically analogous. And secondly, it is not enough to just to gather that data. It's very important that you are validating the data. So again, we'll talk about more on that later. Next down the line is to complete the engineering adjustments for each formation in an unstimulated condition. In this scenario, understand that we're not only doing an H2S release rate for the drilling process, you're also considering completions and producing release rates as well. That's the next step down in the process flow diagram there. So in an unstimulated situation, of course, this is your drilling release rate. As long as you're aware, the flow rates that we're collecting in the H2S search, those are anything from a DST, of course, unstimulated, to post-frac flow rate or an AOF, post-acidization production rate. So any one of those flow rates are going to come at you, and you have to understand which one is more relevant, whether you're choosing a post-stimulated flow rate or not, or just making the adjustments to the existing ones that are chosen. That's up to you. So that's basically what they're speaking to here. Similarly, do the same engineering adjustment for a completion release rate as well. And you are trying to address the drilling and the completions individually. Drilling, you're exposed to all the formations. Completions, it's one or two formations that you're having to address individually. So, determine the H2S release rate for each whole section. I already spoke to that. Just so you understand, in the H2S search, we are summarizing not only the drilling, but the servicing, completion, and the producing. Of course, we don't know which your primary and secondary targets are, so you would need to interact with the report a little bit, plug your numbers into the report, but we can facilitate those other operations as well. And then finally down the line is the well classification for drilling, completions, and producing. The well classification is defined by the ERCB in Directive 56, Table 7.1. You guys have all heard terms to the effect of B140, D570, within that spectrum of are you sweet or are you critically sour, and where do you land in that range? Those classifications are built off of the H2S content and the potential H2S release rate. So getting into the actual cases more specifically, when we're talking the drilling cases, there's a couple of points that are being made and even mentioned in the process flow diagram. If multiple casing strings are cemented in place during a drilling operation, separate the release rates. So you're doing intermediate casing, you drill down to the Jolly Foo, you set casing, you submit, well, anything from the Jolly Foo up is now no longer relevant in your release rate. So if you are going to be cutting those two in half, you can, the H2S search will facilitate that with the split summary sheet tool. But just so you do know, if you are setting intermediate casing, that will play a major factor in your H2S release rate assessment. There's a mention here in the CAPP guidelines. They are referencing similar terminology in the Directive 56 as well, speaking to an assessment of shallow formations above the manville. If there are deep hole, sour formations, what they're essentially saying is you can probably ignore those shallow formations. Appreciate the sentiment that they have in mind. They're basically saying, well, let's not worry about the minor details when you've got sour formations below. It's a tricky one to enforce, however, because following that statement, we have another one saying, unless it is known that the shallower zones may significantly impact the H2S release rate. Well, that sort of undoes the statement, and it's a tough one to understand. So, because how do you know if that shallow zone is sour unless you do the assessment? It's a little bit subjective, and so my advice on this one would be that this is a helpful reminder that you should expect sweet, shallow zones, but I wouldn't necessarily blindly discount these formations just because the CAPP guideline said so or because the RCB said so, just knock out the cardium even though it says it's sweet. Typically, if you're going to see one of these formations as sour, it's probably one erroneous data sample that you can probably just knock out fairly easily, and then you're back to an appropriate assessment for that formation. So I would simply say, you run into one of these formations, if it does come up as sour, have a look at it. It shouldn't be too much effort to deal with that one sample, so then you can come up with a sweet assessment for the cardium. So again, it's more on discounting later. In the drilling case, we're talking again about the pre or post-stimulation flow rates. So when you do encounter a post-stimulation flow rate, as you're collecting all the data samples, we will let you know whether it is a post-stimulation. So if it is an AOF that was recorded after a frac, then you will see that flagged in the report. It's up to you to establish what you're going to do with that post-stimulation flow rate in a drilling scenario. Are you going to take that flow rate and adjust it? And there are some adjustments laid out in Section 5. Or are you going to use a more representative sample? That would be your call. My advice here would be, if it is your target formation, so this is the one you are going to be completing, it's up to you. It's kind of 6 of one, half a dozen the other. You're either going to take that flow rate and work it back to pre-stimulation conditions, so work it back to zero skin, or you're going to use a DST, for example, and anticipate its increased flow in a stimulated situation. So use the best possible sample, and you're going to have to make an adjustment either way anyway. But if it's not your primary or secondary target, you have that option to say, is this appropriate? Is this going to reflect my drilling release rate? So the completion and servicing case, speaking of primary and secondary targets, what they're essentially saying here is you are identifying primary and secondary targets. Unlikely you're going to go after both of them. But likely that the highest release rate is coming from the primary. But in some situations, if your secondary target is more sour, you do need to consider that as your anticipated completion release rate. There are some exceptions that are laid out in the guidelines, but general rule, whichever is higher, that is going to be your referenced formation, your referenced H2S release rate for completions. Vertical flow analysis may be conducted to further adjust from sound phase to surface. There's not a lot that the H2S search can speak to. In fact, not much that I can even speak to in this regard. But it does raise a point that it is important that you are researching the reference well that you are using. So what is your well bar design? How well does the reference well that you've chosen reflect your proposed well? So you got to do some research on that reference well, making sure that it best represents apples to apples. So there's a lot of resources out there to research that information. Excise browse feature is one resource, and I will stress that while I would love to say that we are perfect, there's a lot of data out there, there's a lot of different interpretations of data. We encourage and stress that people are using a second data source. In fact, I believe the ERCB requires it. So yeah, use your AccuMaps, your GeoVistas, and any other data source that you have have access to. That's an important reference material just so you can back yourself up with a different data source. Speaking to the producing case, really what you've done in your completions should reflect your producing pretty closely, but it is important that you are considering flow restrictions. So in a completion scenario, whatever you considered for your potential release rate in that should be your producing. But if you are considering flow up tubing or you have a packer in place, that will affect, of course, your potential flow rate. So consider that. The producing case is also used to establish your level designation. That level designation is defined by the ERCB. It goes from level 1 to 4. And those identify your development restrictions. So again, after this session, if you're unfamiliar with the level designations, follow that link. Now, commingling. When I was reading the CAPP guidelines for the first time, I saw the word commingling, and it raised my eyebrows because I know that commingling is it's an issue right now with respect to the data. As pools get commingled, it really saturates and muddles with the relevance of data now. So unfortunately, that's not what they're talking to here. What they're saying is if you are anticipating commingled, so flow from multiple zones, what they're saying is it's not just a matter of adding the two together for your potential flow rate. They're essentially saying there are considerations for backflow pressures and whatnot. So it's not just a matter of adding the two together. Now, they do touch on another element that speaks to the data, though. If your analog does span multiple formations and it is actually legitimately flowing from both formations, what they're saying here is if you are only anticipating flow for one of those formations, make sure that you are paying attention to that and you're making the necessary adjustments.